All right, I'm doing the proof for De Morgan's laws. So I guess the basic idea is that if we show that each of these is a subset of the other one, then we'll be showing their equivalence. So first, we'll just pick out a random, or we'll take an arbitrary element from the first set and try and show it's in the second set. So let x belong to the complement of x union y. From that, we get that x is not in x union y. From that, we get that x is not in x, and x is not in y. So then from there, we get that x is in x complement and x is in y complement. And this just means that x is in x complement intersect y complement. Yeah, so that's the, I guess, first direction we wanted to show. So we've basically shown that any arbitrary element in this set is also in this set. And now we want to, I guess, show the other direction. So we're going to show that any element in this one is an element in this one. So I'll do that. Let x or little x belong to x complement intersect y complement. From there, we get that x is in x complement and x is in y complement. From there, we get x is not in, or little x is not in big X, and little x is not in y, which just means that x is not in the union of x and y. And yeah, so now we've shown that any element in this set is also an element in this set. So we've shown both directions. We've shown that each of these sets is a subset of each other, which shows their equivalence. And now I'll do that for the other De Morgan's law, or De Morgan law. All right, so it's pretty much the same thing. So I'll say let little x belong to the complement of x intersect y. From that, we get that x does not belong to x intersect y. From that, we get that so if x is not in x intersect y, then x has to be in the complement of one of these. because if this would be true if x was not in the complement of either of these. So from this step, we know that x is in x complement or x is in y complement. And then this is just this condition. So x is in x complement or y complement. All right. Now we want to show the other direction. So we'll say let x belong to one of these. So then we have x is in x complement or x is in y complement. So because x is in, it has to be in at least one of these, we know that, we basically know that x is not in either x or y or both, because x is in one of their complements. So from here we can get that x does not belong to x intersect y. And from it follows from that x does belong to x intersect y complement. So we showed that some arbitrary element of this is also in this, and before we did it the other way around, so we've shown the equivalence between these two sets. And that is the proof of the second De Morgan's law.